Welcome back to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.3, day 2, entitled Algebraic Expressions. And our objective for today is going to be factoring trinomials and doing special factoring formulas like the difference of two cubes or the sum of two cubes, and then factoring by grouping. So we're going to start by factoring trinomials. And in example 9 here, this very first problem, problem A, should be very familiar. All three of these we're actually going to use a guess and check type of a method, although part C does have a special name. That's a perfect square trinomial. But this is all a type of factoring that you've seen before and you've done before. So for part A, when you have an expression like this with a trinomial, you have your x squared and your minus 2x and then your minus 3. You want to ask yourself, okay, what are the factors of 3 that will add up to a negative 2? And when we use the guess and check method, that's most commonly what it is called, you want to set up your two sets of parentheses, and then you're going to say, okay, what times what is x squared? Well, that's got to be an x and an x, so x goes in the first place in each parenthesis. And then what are the factors of 3? You need a 3 and you need a 1. And now you have to ask yourself, okay, how can I get a 3 and a 1 to add to a negative 2 and multiply to be a negative 3? Well, if I make the 3 negative and the 1 positive, the negative 3 and the 1 will add to a negative 2 and multiply to a negative 3. So if I FOILed this all out again, I would have x squared plus 1x minus 3x minus 3. And then if I combine my like terms, I would get the x squared minus 2x minus 3 back again. So this factoring is where you're basically changing addition and subtraction into multiplication. So I took that trinomial and I found the two binomials that you would have to multiply together to get the original trinomial. Now part B, this is new, this type of expression, the way it's written. This you haven't seen before. So this is definitely pre-calc level. This is the type of problem I would expect you to be able to do on a quiz. And here we're going to basically think of this expression like our trinomial that we had in part A. This whole thing in the parentheses, this 5a plus 1, I'm just going to think of that kind of like x squared. And then I have a minus 2, and then again I have the 5a plus 1, just like I had over here. So that's kind of like negative 2x or minus 2x minus 3. So essentially it's the same as what we had in problem A, except instead of an x, we have a 5a plus 1. So it doesn't matter what is in those parentheses or what is in the x place, we're still going to factor like we did before. So I still need two sets of parentheses. I'm going to make them a little bit bigger because we're going to have some more terms that are going in here. And instead of asking myself, okay, what times what is x squared, and putting an x and an x, I'm going to put the 5a plus 1 in that x spot. Because 5a plus 1 times 5a plus 1 is 5a plus 1 squared. And then I still need the factors of 3. So the factors of 3, that would add up to a negative 2, would be a 3 and a 1, and I'd have to make the 3 negative and the 1 positive. Now the only other thing I'm going to do to this problem is I'm going to simplify the terms inside the parentheses. I'm kind of smushed for room here, so I'll write it over to the side. So my first set of parentheses, I have the 5a, and then 1 minus 3 gets me a negative 2, or minus 2. I still have my 5a, and 1 plus 1 is 2. So if I multiplied these binomials together and combined all my like terms, And even if I multiplied out the original problem and combined all my like terms, I would get the same thing. So you just want to think of whatever's in the parentheses. Just think of it like the x term. And over here, this is a minus 2x. Just think of the 5a plus 1 like an x. And then it follows the guess and check pattern. Now part C, you can still do guess and check with it, but it's a perfect square trinomial. And we know that because I've got a 4 and an x squared. 4 is a perfect square, and x squared is a perfect square. Then I also have this y squared as well. So I can still break this apart into my two sets of parentheses. And I can still say, okay, what times what is 4x squared? Well, that's a 2x and a 2x. And then what times what is y squared? Well, that's a y and a y. And then how do I get those to get me to a negative 4y? So when you're doing this, you want to kind of check your outers and your inners. So my outers, if I multiplied those together, I would get a 2xy. And then on the inside, I'd have another 2xy. So those are my like terms that I would be combining together in the middle if I were to actually FOIL this all out. So a 2xy and a 2xy, that would add up to a 4xy altogether, which is my middle term here. But I want it to be a negative 4xy, so I'm going to make that a minus and a minus. And then we want to rewrite this. We want to simplify it just a little bit. We want to rewrite it as 2x minus y squared. Since the stuff in the parentheses is exactly the same, we're just going to simplify it and write it as 1 parenthesis squared. Okay, now we also have some special factoring formulas. The difference of two squares, you should be familiar with that one. Perfect squares, you should be familiar with those. That's basically guess and check, like what we just kind of did. But the sum and the difference of two cubes, that you should have seen in Algebra 2, but depending on who you had and how much they emphasized it, it's probably a higher level skill in Algebra 2, but now it's something that you definitely have to master. You have to know how to do a sum and a difference of two cubes. And basically, you've got your first term and your last term, so you take the cube root of each of them. So if I have a cubed plus b cubed, then I have the cube root of a, which is a, and the cube root of b, which is b. So that's how I get the terms in my first parenthesis. I keep it addition because I have a sum of two cubes, so I'm going to keep the sum there. And then to get the second set of parentheses, I take my first term and I square it. I take my b term and I square it. So that makes the first and the last terms in that second set of parentheses. And then to get the middle term, I just multiply a and b together. And that's going to be the pattern for both 4 and 5, except the signs change. So watch the signs here in this fifth formula. I have a plus, and then it's minus plus. So they kind of alternate. When it's minus first for a difference of two cubes, it's minus and then plus plus. So really, if you can remember that pattern, you really just have to emphasize where the signs are and where the pluses and where the minuses are as you factor. So we're going to practice one of each. We're going to practice a difference of two cubes and a sum of two cubes. And that chart that was on the previous slide, that's in your book. So if you want to look at that while we're going through these, feel free. So I have to look at my two terms here. I have a 27x cubed, and then I have a 1. So those are what I'm going to find the cube root of. So the cube root of 27 is 3, and the cube root of x to the third is x. So 3x is my cube root of that first term. And the cube root of 1 is 1. So there are the terms in my first parenthesis. Since it's subtraction, I'm going to keep that subtraction there. And then for my second set of parentheses, I need 3 terms. I need a trinomial here. So to get my first term in the parentheses, I take my first term here and I square it. So 3x squared is going to get me 9x squared. And then to get my last term in that trinomial, I'm going to take this second term here and square it. So 1 squared is going to be 1. And then to get the middle term, I multiply those two terms together, the 3x and the 1. Well, 3x times 1 is just 3x. And then I just have to fill in my signs. And if it's subtraction here, I'm going to have plus plus in my other parentheses. And you're done. Okay, so part B, similar concept, except it's addition, so the signs are going to change. I still want to start by finding the cubed root of x to the 6th and then the cubed root of 8. Now when you're finding the cubed root, remember we're taking the cubed root of x to the 6th, so we're dividing that exponent by the root. So 6 divided by 3 is going to be 2. So x squared is the cubed root of x to the 6th, because I would need 3 x squareds multiplied together to get x to the 6th. So that should make sense to you. And then I need the cubed root of 8. You should know the cubed root of 8. It's a very common cubed root. It's 2. If you don't know that, you can do that on your calculator too. The math menu in your calculator has a cubed root function already programmed in. And then it's a sum, so I'm going to add those two terms together. So there's my binomial in my first set of parentheses. Now I need my trinomial in the second set of parentheses. So I'm going to square my first term. So that's x squared squared. So that's going to be x to the 4th. And then I need to square my second term. So that's going to be 2 squared, which is 4. And then I need to multiply them together. 2x squared. Now I just got to fill in my signs. So if it's addition here, it's going to be minus plus. They're going to alternate all the time. And you're done. You factored. Now, when we are factoring, sometimes it's not just a one-step type of factoring that we have to do. You're going to see problems where the directions will say to factor the expression completely, and that means you might have to do more than one step. So if you see that in the directions, it's kind of a clue that you might have to take out a GCF first and then do a difference of two squares, or take out a GCF and then do guess and check, or take out a GCF and then do a sum or difference of two cubes. So it's just a little clue that these are going to be multi-step problems. So this is what they will look like. Notice the directions say, factor the expression completely. So the very first thing that you always want to look for, always, 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 is taking out a GCF. That should always be your first step. And usually it's one that students overlook because it's such a easy type of factoring, you kind of forget that it is a type of factoring. Okay, so we're going to look for our common factor. You want to look for a numerical one and a variable factor. So notice I have a 2 and an 8, so I can take a 2 out of both of those. And when we were looking for a GCF in the previous day's notes for variables, remember I said the clue is to take the smallest exponent. So I'm going to take out an x squared from each of them. So then that leaves me with x squared minus 4. Now before you just say, yay, I'm done, and you walk away, look at what's left over in the parentheses. Those are my little leftovers. That is a difference of two squares, so that can be broken down further. So when you have a difference of two squares, remember you need two sets of parentheses. You need an x, and you need the factors of 4, so you can have 2 and 2. And difference of two squares always has opposite signs. One's a plus and one's a minus. And if you were to FOIL that back out, you would get the x squared minus 4, because your middle terms are going to be a 2x and then a minus 2x, and they're going to cancel. So really, it's kind of like doing guess and check with an x squared plus 0x minus 4. So we're trying to get the factors of 4 that are adding up to 0. So we need 2, and one has to be positive and one has to be negative. And then we still need to bring down this GCF that we factored out before. So now after we've taken out the GCF and then we've done our second step, which was a difference of two squares, now we have factored it completely. I can't break any of those terms down any further. Okay, last type of factoring is factoring by grouping. And this is where you're going to group two terms together and take out a GCF from both of them. Now you can group the first two terms and the last two terms, or you can group the first and the third and the second and the fourth. Doesn't matter. Two different people could do the problem two different ways and still get the exact same answer at the end. Okay, so I'll do part A where I'm grouping the first two terms together and the last two terms together. And then I'll do part B the other way. So if I look at x to the third and x squared, their GCF would be an x squared. And then the leftovers for just those two terms would be an x plus 1. Remember, when you take out a whole term, it's kind of like dividing an x squared by an x squared. You're dividing it by itself. So there's a 1 left there. Don't just leave it empty. That's a common mistake. And here, for these other two terms, the 4x and the 4, I'm going to take out a 4 as their GCF. So that leaves me with an x and then a plus 1. Again, because 4 divided by 4 is a 1. Now the stuff in the parentheses matches. That's how you know you did the grouping and the taking out of the GCF correctly. And the other step then that we have to do is we have to take the GCFs that we took out and we have to put them into their own parenthesis. So we have x squared plus 4 that goes in a parenthesis. And then you just write the x plus 1 one time. Don't square it. I know there's two of them, but what we're really doing here is kind of like undoing a distribution. It's kind of like the x squared and then the x plus 1 has had an x plus 1 given to it. And the 4 and the x plus 1 has had an x plus 1 given to it. So we're kind of taking out the x plus 1s that they had in common and just putting the other terms together in their own little parenthesis. So don't write x plus 1 squared. I know there's two parentheses. I know it's tempting to think that, but actually it's incorrect. Okay, so for part B then, I'll do this type of grouping the other way, where I group the first and the third term, and then the second and the fourth term. Now you could still do this problem where you group the first two and the last two. It'll still get you to the same answer. I'm just demonstrating both methods. So in my first term and my third term, if I look at them, the only thing that they have in common is an x. So if I take an x out of x to the third, I'll have x squared. If I take an x out of a negative 3x, I'll have the negative 3 or minus 3. And then my other two terms, if I look at the negative 2x squared and the 6, the thing that they have in common is a 2. But I'm actually going to take out a negative 2 because this first term in the little group has a minus. So when I take out a negative 2, that'll leave me with a positive x squared and a minus 3. So if I hadn't taken out the negative, if I had left this positive, then I would have had a negative x squared and a plus 3, and my signs would have been opposite from one group of these parentheses to the other. So that would have been a little clue that I could have caught. I could have gone back and said, oh, it needs to be a minus here. So now, since I took out that minus, the stuff in the parentheses matches, which is exactly what we want. I did it correctly. I did the grouping correctly. I took out the right GCFs. So now I'm going to take those GCFs and I'm going to put them in their own parenthesis, x minus 2. And then I'm going to rewrite the common parenthesis just one time. And then that's it for that one. Now watch out for these problems too, because sometimes when you group them and you form these two parentheses, like this x squared minus 3, I can't factor that anymore. But if it was an x squared minus 4, that would be a difference of two squares, and I could break that down further. Okay, so watch out for a type of problem where you have to factor by grouping and then do some other type of factoring to factor completely. So there are your practice problems for this homework set. If you have any questions, come on in before school and see me. Good luck. Do well.